This lesson deals with the complex plane and Des Moines theorem. Now, complex numbers, you're used to complex numbers, a plus bi, the normal way that you see them. But we could just as well say x plus yi, because a and b, x and y, they're just numbers. But when we think about it this way, we can think about it on a rectangular coordinate system and let the real part be the x, the first part of the complex number, and the imaginary axis be the y value. And then we can plot points on here, just like you can plot points on a rectangular coordinate system. So if we had the complex number, square root of 3 minus 1i. So z is our complex number. So square root of 3 is equivalent to x, minus 1 is equivalent to y. So square root of 3 right, 1 down, and we have graphed the complex number. Now, if we want to look at it in a polar form, okay, the complex number, we would need this distance, the distance from the origin to the point. And that distance is called the magnitude or the modulus. And we do it by putting two lines, absolute value idea, on z. And it's the same as our r, the square root of x squared plus y squared, just like we had before. So we can convert complex numbers, a plus bi, we can convert them into polar form. Convert them into polar form, right, by looking at x being r cosine theta, y being r sine theta. So if we have a complex number, x, yi, we have z, we have the angle, and so the complex number x plus yi, x is r cosine theta, plus y is r sine theta I. We've got r's in both. So r cosine theta plus I sine theta. This is the complex form of a imaginary number. So this is the standard form of a complex number. This is the polar form of a complex number. So we should be able to convert pretty easily because it's the same thing we've done before. So here's a complex number, square root of 3 minus 1i. The x value is square root of 3, so you square it. Y value is minus 1, so you square it. Take the square root and you get 2. There's r. And sine of the angle is y over r. Cosine of the angle is x over r. Or from the last section, the tangent is y over x. So we put those values, and then we have to remember back to the first section of the chapter. Cosine of theta related to 1/2 is pi over 6. But because this is right and down, it's the fourth quadrant. So the fourth quadrant relative of pi over 6 between 0 and 2 pi is 11 pi over 6. So 2 cosine 11 pi over 6 plus I sine of 11 pi over 6 is our complex number, square root of 3 minus 1, standard form. Here is the polar form. The polar form is very useful in multiplying, dividing, raising to powers, or taking roots. It's not a very good way to do it if you're adding or subtracting. If you're adding or subtracting, it's better in standard form. Multiply and divide will work either way. Raising to a power, taking a root, complex, the polar form is much easier. And so there are 4 formulas that you need to be able to work with. And there's some formulas you already know, r cosine theta, r sine theta, those kinds of formula. But if you have 2 complex numbers in polar form and you want to multiply them, the way you do it is you multiply the r's and you add the thetas. If you want to divide, you divide the r's and you subtract. In the order, you subtract the thetas. It's how you figure out doing complex numbers and adding or multiplying and dividing. So, real quick, 3 cosine 20, I sine 20, that is a complex number in polar form. 5 cosine of 100 plus I sine of 100, that's in polar form. So to multiply, you multiply the r's. 3 times 5, so that's 15. And you add the angles. 20 plus 100 is 120. So 15 cosine of 120 plus I, the sine of 120 degrees, is the product of these two numbers. Divide, you divide in the order that you're doing it. So z over w. So z, 3 divided by 5. And you subtract in the order z, top, w to the bottom. So 20 minus 100 is minus 80. And if you are looking at putting it between 0 and 360, right, you would add 360 to these two numbers and get 280. So 3/5 cosine of 280 plus I sine of 280 degrees is the quotient of those two numbers. The next formula is called Des Moines formula. If you have a complex number in polar form and you now want to raise it to a power, square it, cube it, fifth power, whatever power you're raising it to, you take the r component and raise it to that power, and you take the angle and multiply by that power. So 2 cosine of 20 plus I sine of 20 cubed. So we're going to cube it. So you take 2 and cube it, and you take the angle and multiply it times 3 using the formula. Do that, you get 8 cosine 60 plus I sine 60. If we want to put that into standard form, we get rid of the sines and the cosine. But cosine is 60. First chapter is a half. Sine is 60. Square root of 3 over 2. 8 times a half is 4. 8 times square root of 3 over 2 is 4 square root of 3i. And we have converted it. One more formula. One more formula in this section. Right? If you want to take a polar, or take a complex number and take it and find the square root or the cube root or the fourth root, whatever root you want to find, you can't do it in standard form. You have to put it into polar form. So if we have our complex number in polar form and we want the nth root, square root, cube root, fifth root, whatever root we want, you take the r and you take the root of it. If you're looking for the square root, you take the square root of r. And cube root of r. Fifth root of r. Then you take the cosine of the angle and divide that by the root. Square root divided by 2. Cube root divided by 3. Plus 2k pi over that number. Plus I, the sine of the same thing. It's a formula. It's a plug-in. But what happens is you get as many roots. You get as many roots as there is n. So if n is cubed, you're going to have 3 answers. And the way we find those 3 answers is we first put 0 in for k. And now this is in degrees. This would be 360k. Then you put 1 in. Then you put 2 in. And you keep going to whatever root it is. For example, here's a complex number. Minus 1 plus the square root of 3i. Well, I want the cube root of that. And I do not know how to take the cube root in this form. I only know how to take the cube root when it is in polar form. Then I can use this formula. So I've got to convert it. So minus 1 squared and 3 squared. That's 1 plus 3, 4 square root. That gives me 2. Right? The cosine of the angle is minus 1 over 2. That's related to 60 degrees. Because they said put this one in degrees. And cosine of an angle, the x value over r. So minus 1 over 2. But since this guy is left and up, this is second quadrant. So the second quadrant relative of 60 is 120. And so 2 cosine of 120, I, the sine of 120, is the polar form of this complex number. So to find the cube root, You take the 2 and you take the cube root of it. So cube root of 2. You take the angle, in this case 120, and you divide by the root. So 120 divided by 3 plus 360 divided by 3 plus 360k divided by 3 plus I, the sine of 120 divided by 360k. So we get the cube root of 2, the cosine of 40 plus 120k, I, the sine of 40 plus 120k. Since this is the cube root, there are 3 answers. And so we find the 3 answers by using the first 3 values, 0, 1, and 2. So we put 0 in for k. We get I, the sine of 40 plus 0. And so we get the cube root of 2, cosine of 40 plus I, sine of 40 degrees. Then we put 1 in. So 40 plus 120 is 160. So it's the cube root of 2, cosine of 160 plus I, the sine of 160 degrees. Then we put 2 in. That's 240 plus 40, 280. So the cube root of 2, cosine of 280 degrees plus I, the sine of 280 degrees. And so everything in this section is a formula to use. We need to be able to first convert from the rectangular form, the standard form, to the polar form. Once we've done that, then we can use these formulas. We can use these formulas to, there's our conversion, but then we can use these formulas to, one formula, multiply. Second formula, divide. Third formula, Des Moines theorem, raising it to a power. And the fourth formula, raising it, taking the root of it. This one, I have to be in polar form. I can do the other pieces in standard form, just easier in polar form. But this one I must do in polar form. And remember, if you have a complex number and you're taking the 5th root, there are 5 answers. If you're taking the 4th root, there are 4 answers. And we plug into here, and then we start substituting k0, then 1, then 2, till I get the correct number of answers. I'll do a problem or two on the root piece. I'll do a problem or two on the root piece. The others you should be able to get pretty good. Look at the videos, look at the other information,